All right, so now we're going to begin questions on the homework.
Number
7. Identify the surface whose equation is given by rho equal. Well, it's sine p sine theta. What surface is that? It's a sphere. What's the center? How do you know that? You could transform it to rectangular. I could multiply both sides by rho. I get rho squared is equal to rho sine phi sine theta. This guy I know is x squared plus y squared plus z squared. This guy I know is y. So I just bring that over, complete the square. I get x squared plus y minus 1/2 squared plus z squared equals 1/2 squared. So it's a sphere centered at 0, 1/2, 0 with radius 1/2. Other questions? Sketch the solid described by, so this is the sketch. Rho between 2 and 4, phi between 0 and pi over 3, theta between 0 and 5. Okay, how does that look? Alright, well these are two spheres, but we're slicing into them, right? So that's why that's x. That's z. So there's a sphere of radius 2. We're only talking about the part that's between, like the trace is going to be so this is a sphere of radius 4, that's a sphere of radius 2. But my phi only goes where? Down to pi over 3. So. I don't know, this angle is sort of weird. It would look sort of like that. Trying to change the perspective here so you can sort of see it. So that here would be where the x is going, the y is going back there, and the z is going here. So this outer one is on the sphere of radius 4. And this one is on the sphere of radius 2. So I'm in between two spheres, but then I just cut it off. So it would sort of look something like that. kind of word to draw. Other questions?
So in general, on the final, they actually have to sketch it and, you know, basically.
No, like questions like these wouldn't show up on a
Oh,
card.
they won't show up.
They might ask you, they might describe this in words and then ask you to integrate on it or something like that. And then you would have to figure out these limits. Other questions?
Thank you.
37. I don't have that. 37. Evaluate the integral by changing two spherical coordinates. So this is a good problem. Good practice problem. All right, how would that set up? How would we set that up? How do we figure it out? First thing we do. How do we know what the sketch is?
First one. That's the first one to do.
Huh?
You look at it with the y-axis, and then it's like a semicircle.
So if I look at it in the xy plane, that means my y is going between 0 and this guy, which is a semicircle, and my x is going between from 0 to 1, which means it's a quarter circle. So that's what I have. So automatically from that, I know that my theta is 0 to the power of 2. Okay, so far I know that piece of information. What else do we know? Now you can look at the z, of course. So z goes from this, which is a cone, up to that, which is a sphere of radius radical 2. So basically what we look like is a cone, sphere centered at the origin, radius radical 2. And then what is going to be this intersection point? You have to like set these equal to each other, right? So I would have z squared is equal to 2 minus x squared minus y squared, and also z squared from the bottom is equal to x squared plus y squared. Right? So I can set these two equal to each other, and the result would be x squared plus y squared equals 1, right? And so, which that actually is the equation for this part, but we only care about the first quarter of it. So this projection here, we only care about this part of it. Okay, so now that we know that, what do we need for spherical? So I already know the theta. What's the phi and what's the rho?
You know the phi has to be from 0 to power of 4.
Right, so that we've already talked about more than once. That cone gives us the power of 4 as the angle, so that's 0 to power of 4. And the rho?
0 to
So it measures from the origin, extending to the outer surface, which, because it's extending to a sphere, it's always going to be the same. It's going to be a constant radical 2. So our integral, this guy, I, is just 0 to pi over 2, 0 to pi over 4, 0 to radical 2. What's x times y? Rho squared sine squared phi cosine theta sine theta. Or you can use the double angle form for sine and rewrite that. Times rho squared sine phi d rho d.
Sorry.
Everyone is so dramatic. Okay. And yeah, you do that. Did they actually validate it? Yeah. From there, it's just sort of stupid, right? So if I were evaluating this, I would have written it as something like 1/2 rho to the 4th sine cubed phi sine 2 theta.
And can you completely just separate each one since none of them are related?
I could. So because in my limits none of the variables show up, and I could have thought of this as, yes, I can separate each one. I can do 1/2 the integral from 0 to radical 2 of rho to the 4th d rho multiplied by 0 to pi over 4 of sine cubed phi d phi times 0 to pi over 2 of sine 2 theta d theta. Yeah, because the variables don't mingle. I can separate them as products of functions where it's up each variable. And the limits don't have any of the variables in them, so I can literally do that. Right? This guy is just a substitution. You take off a sine, change sine squared to 1 minus cosine squared phi. U equals cosine here. So yeah, each of these are easy to do under it. Other questions? So whenever you see something like this, you just start writing out the equations. This just means z equals this, z equals that. That you know is a sphere, this is a cone. Then you know that y must be equal to this, and y equals that. That you know is a circle, that's a line. This is x equals 0 to x equals 1.
You gotta evaluate that in the order?
Yeah, you have to like do that, but that's okay.
We
That's
do it
easy.
with 25.
So 25 says we want to evaluate the triple integral of e x e to the x squared plus y squared plus z squared dv. E is x squared plus y squared plus z squared less than or equal to 1 in first octave. Okay, so we're inside the sphere of radius 1, the ball of radius 1, and it's in the first octant, so what's my theta, what's my phi, what's my rho? First octant, theta is what? Phi is what? Also 0 to pi over 2. Rho, 0 to 1, because it's inside the sphere of radius 1. So basically this guy becomes 0 to pi over 2, 0 to pi over 2, 0 to 1. My x becomes rho sine phi cosine theta, e to the rho squared times rho squared sine phi d rho dv. Did you get to that setup? Okay, so also not a bad integral to do. This is rho cubed e to the rho squared times, will be slightly annoying, but it's not hard, times cosine. You can separate them again. So if we focus on this guy, what's that going to be? It's integration by parts. You start out with a u substitution, u equals rho squared. It's going to kill one of the rows here. I'm still going to have a rho squared that I have to do by parts on. This one, how would you do that one? The half angle formula, right? This says 1 minus cosine 2 phi all over 2, and this one is just integral of sine. So each part is not so bad. Did you try to not get the answer, or what?
Yeah, I did it. I think I messed up with the integration by parts of the piece. That was my problem. When I got an answer, people.
Okay. Let's actually work it out. So, yeah, like we said, we can actually separate these ones. So if we look at 0 to 1 of rho cubed e to the rho squared d rho, do like a u substitution, du will be 2 rho d rho. So then I end up with 1/2 times the integral of e to the u du times u. And what are my new limits? So when rho equals 1, u equals, when rho equals 0, u equals, when rho equals 1, I plug in 1 here, my u is also 1. If rho is 0, my u is also 0. So this is still 0 to 1. And so this is, let's do tabular method, e to the u, e to the u. So this is 1/2 times, so it's u e to the u. Then minus e to the u. So if I plug in 1, I get e minus that part's a half. Did you get a half for that part? Did you do it separately like this? Okay. So that part you should get a half, right?
I didn't change it to you.
Okay. Well, you should end up with a half, however you did it.
I did a slightly different one. I said I did like u is equal to p squared, and then dv is equal to e to the p squared, and then.
Oh, you just did by parts on that form?
Yeah.
So you said u equals p squared and dv.
P e to the p squared.
It's the same thing. 'Cause
It's the same thing. It'll be the same thing. Right, because when you integrate this, you're going to get 1/2 e to the rho squared, right?
Yeah.
So that 1/2 is this guy here. And then this guy is just the u. So e to that part becomes that. It's equivalent. It's the same thing. It's just that some people wouldn't see it that way, I think. It's nicer to visualize if you just do a substitution. Then you'd worry about the part that says 0 to pi over 2 of sine squared phi d phi. Well, we know that we just treat this as 1/2 1 minus cosine 2 phi d phi. And so that's 1/2 phi minus 1/2 sine 2 phi 0 to pi over 2. Well, in either case, this guy is going to give us 0. And so we pretty much end up with 1/2 times pi over 2. Then you worry about the last integral, which is just 0 to pi over 2 times cosine theta and theta. Which which is just sine theta. Just one. So, what was the answer? That was it?
Yeah.
So where did you mess up?
Not sure. This is slightly different. Don't want to do it now.
Okay. That was it. Other questions? Okay, so well, there's not much time to do anything else, so if you have any other questions, I guess we can end there. So yeah, remember I sent the email yesterday? So 2 tests left. One is on December 1st, the other is on the last day of class, and we have a MATLAB final on December 4th, which it's something you'll do in class. What is happening? Yeah?
Can you tell us which focus we're gonna have to do on the MATLAB file?
No. So basically, yeah.
Are we going to have partners for the test?
No, you're not having a partner. That's what I'm going to explain now. So it's going to be split into 2 parts. So I have to write 2 versions, and half the class takes it at once, then the other half takes it afterwards. You will be allowed to use source material. So you're gonna have your notes. You're gonna have the help on the MATLAB. You're gonna have Google even if you want. So basically, I'm just gonna give you some time to just basic stuff. Graph this surface. Compute this integral. Label your graph properly. Put a legend on it. Things like that. It's the visual stuff is what I really care about here. So yeah, I'm just gonna ask you to do a bunch of things like that.
So we can use GUI method if we want.
Huh?
So we can use the GUI method if we want. We don't have to type all the code. But we don't have to type in the code for a legend if we know how to do it in the GUI method.
Yeah. Well, some code will be necessary, but
Oh,
yeah, to like sexy up the graph, I guess use the template. I don't really care. Yeah, so that's what it's gonna be like. So, but yeah, you won't be working with a partner, so you have to know how to do it on your own. Or if you don't know how to do something, know how to look up how to do it, so that at any moment you can just sort of figure it out quickly. It shouldn't be long. I'm going to ask you a few simple problems. I just want to know, do you know how to navigate this program and figure out how to do things? Yeah. I know some of you have been using it to check your homework, so you've already familiarized yourself with just doing some basic functions in it. But yeah, that's basically what it's going to be like. Any other questions? Okay, I guess we can stop there, pass up your homework, and we'll finish sequences next time.